This is your lesson on properties of logarithms. This is for Monday, 3:30, Unit 10, Lesson 1. Properties of logarithms. 3 properties, and I would suggest you also take a look at the notes that were posted for these and for examples. But the properties, first one is log base b of m times n. So what I have is 2, it could be more than 2 elements being multiplied. If they are being multiplied, it's equal to log base b of m plus log base b of n. In other words, each element, in this case m and n, get their own logarithm of the same base. And the 2 logarithms are being added when the elements are being multiplied. Likewise, the second property is the same thing, only with division. If m and n are being divided, each element gets its own logarithm of the same base, but the 2 logarithms are being subtracted since it was division. The last property says that if something has an exponent, that exponent comes in front and becomes the coefficient of the logarithm. This can also be used the other direction, that if I'm adding 2 logarithms of the same base, I can condense them into 1 logarithm being multiplied. If 2 logs are being subtracted, I can condense them into 1 logarithm where the elements are divided. And if I have a coefficient, I can bring that coefficient up front, up top, to become an exponent of x. So we're going to do 4 examples. First, we're going to expand log base 3 of 4x to the 6th. So that means I have 2 elements here, 4 and x to the 6th. They're being multiplied. So I'm going to take 2 logarithms. I'm going to take log base 3 of 4 and log base 3 of x to the 6th. Now I've expanded it, given each element a logarithm. Because they were multiplied, I'm going to add them together. So it's going to be plus, both logarithms are going to be added. I do have one other property to use. There is an exponent here. So I'm going to take that exponent, get rid of it here, and I'm going to move it out in front to become a coefficient. Now I've expanded this logarithm to have log base 3 of 4 plus 6 log base 3 of x's. Second one, we're going to expand. So again, I have 3 elements this time. X to the 3rd, 3, and y squared. So we're going to give each one its logarithm. So natural log of x to the 3rd minus, because I'm dividing, natural log of 3. I also have y squared, so I'm going to give that its natural log, y squared. But they're both being divided, so they both get a minus sign. Now I'm going to take those exponents and bring them out in front. So it's going to be 3 natural log of x minus the natural log of 3 minus 2 natural logs of y. And I just brought those exponents out in front to become coefficients. Now there is another way to write this. You can also write this as 3 natural log of x minus, and do it as subtracting the entire quantity of natural log of 3 plus 2 natural log of y. Now why would I write this? Well, I see that these 2 are being multiplied, which means plus, and I'm dividing this as an entire quantity, so I subtract the entire quantity. I would accept either of these 2 answers. Now let's do some condensing using the properties the other direction. So I have 2 logarithms, both in base 10, so I can combine those into 1 log base 10. I have 8 and 2 as the 2 elements. Subtraction means to divide the elements. So I'm going to take 8 divided by 2, which is simply log of 4. Second one, to condense, I see I have coefficients. I'm going to use that last property first. We're kind of going backwards when we condense, so I'm going to use the property of the exponent, the third property. I'm going to use that first. I have the natural log of 2 to the third plus the natural log of 7 plus the natural log of x squared. And I just simply took the coefficients and moved them up to become exponents. Now this is 8, we'll change that in a moment. But now I can condense these. I have 3 natural logs, so I'm going to combine them or condense them into one natural log of, well, we're adding, so we're going to multiply 8 times 7 times, because again we're adding, x squared. So that is the natural log of 56 x squared, final answer. And I've condensed all of those logarithms down into one logarithm.